Hello everyone, my name is Mustafa Gudarzi, a PhD student at the University of Central Florida. I am really happy for this opportunity to present my paper. Its title is Fast Security Evaluation for Operation of Water Distribution Systems Against Extreme Conditions. This paper is the result of my research work as a PhD student under supervision of Professor Lee and in collaboration with Mr. Dan Wu. At first, I want to discuss the importance of water security, that is defined as water consumer accessibility to an adequate quantity of water with acceptable quality. One of the issues in water security is the imbalance between supply and demand. And this imbalance is subject to water pipe limit, and water engineers try to overcome this issue. The optimal pump scheduling that is defined as finding the optimal operation schedule of pump by considering the nodal water demand as a forecasted value is one method to avoid any imbalancing between demand and supply in water network. Indeed, operator of water distribution network minimize the cost of power demand of the water pump by optimal pump scheduling, because the power price varies at different time of the day. The water distribution network operators assume that the prediction of the nodal water demands are exactly correct. However, in the real world, a water consumer may need more or less water than the forecasted value. So the OPS cannot guarantee the water security when the prediction water demand is different from the real-time water demand, especially in extreme conditions. Therefore, the evaluation, the security of a water distribution system is an important issue for demand side, especially for interconnected system. Because in the real application, interconnected system conflict prevents their actual real-time model from being shared in a co-optimization. So two interconnected systems do not share their actual model with each other, but by defining the security injection region that we define in this paper, we can help to consumer, such as power plant, to evaluate network security and cope with any extreme situation by sharing some good information between two interconnected systems. So in this paper, we define the security injection region. We provide a flowchart that shows our method for fast security evaluation for operation of water distribution against extreme condition. At first, we modeled the water distribution system with forecasted nodal water demand by considering the pipe network model, pump model, and the mass flow conservation law, and some upper and lower constraint. For example, mass flow conservation law is related to water injection to each node is equal to water output of that node. After the modeling the water distribution system with forecasted water demand, the OPS will be solved, and the status of the pump will be known. For each time of the day, the pump is on or off. So the S, the variable S changed to parameter, and we know the S in our system. Then we go to the blue section that's related to water network. The operator of the water distribution network select some node to execute the algorithm 1 on them that I will explain the algorithm 1 in the next slides. And then the SIR will be provided for selected node and post it to the interconnected system in this part of flowchart. And the interconnected system can check the feasibility of water demand with this SIR or security injection region. If it is feasible, the operation of this interconnected system will be secure. If not, this system should update their water demand and put it in the initial problem. And this algorithm should be do again to reach a SIR. We consider the assumption for convexification of water security injection region. First, water distribution has a tree structure, and the second, that is all node pressure ranges are similar to each other. In this slide, I want to explain the algorithm one. This algorithm is the estimating convex security region based on constructing monotone inner polytope sequence. I explained this algorithm with an example. Assume that we want to find the security injection region of two nodes in a water distribution system. At first, we find the acceptable maximum of water demand for each node based on water network constraint and construct the starting polytope. You can see the black circle here as an acceptable maximum water demand, and the blue section show the starting polytope. Then we use the orthonormal direction of this line to define the objective function related to these two nodes and find the maximum value of this objective function by finding the blue circle, and then add the red section to polytope and find the first polytope. We continue this procedure for these two lines and find the red circle and construct the second polytope. And this procedure continue to reach the security injection region, the starting polytope, the first polytope, and the second polytope. We execute this method on two different case studies. We consider for the first one, we consider node 5, 8, and 9 as the node that we want to find the security injection region. This is the starting polytope that is constrained by acceptable maximum water demand for each node. And by executing the algorithm one, the first, second, and third polytope will be constrained. This is the first polytope. This is the second one. And this one is the third polytope. We execute the same procedure for the other case studies. For this one, we consider node 3 here, 5, and 9 as a flexible load, and other node considered as a fixed load. You can see the starting polytope, the first polytope, second polytope, and third polytope. Our method is very fast and reach the security injection region after 3 or 4 polytopes. Besides, you can see for each polytope, we need less than 0.5 seconds to construct the polytope. So the speed of this method is very good, and this method is very fast to reach the security injection region. As a conclusion, we can set in this paper, a concept of security injection region is introduced for guaranteeing the security of water distribution operation. We show that the security injection region is a convex region under some mild conditions. A sequential optimization approach based on the monotone inner polytope sequence is applied to effectively calculating the security injection region of water distribution system. And the numerical studies on two different case study show that the optimization solver reached to optimal solution very fast and constructing the convex region in the acceptable time. And the almost whole convex region is determined only requiring 3 or 4 iterations. Thank you for attention.